Is it okay? Then divergence of E equal to, if I take the derivative, then what happens? E naught e to the power I kx minus omega t d by dx I kx minus omega. Is it okay? Then it will be k, I k will come out. It will be e, this whole term will become e, and I k. Is it okay? Now if I cancel e, so divergence equal to I k. Is it okay? Short term. So no need to do anything. Divergence is always replaced by I imaginary number into k vector. Similarly, if I del equal to, I have already find out I k. This is a short term. How to reduce your time in exam. So similarly, if I take the del e by del t equal to how much? If you take the derivative with respect to time, a whole term will come out e naught I kx minus omega t, okay, then minus I omega. Is it okay? And this is become e into minus I omega. So so first important relations, important point one, that is del is always equal to I k. Remember, once I find del, I will replace del equal to I k. Similarly, if I take the del t, see again I am telling it del e by del t. Del e by del t equal to e naught e to the power I kx minus omega t minus I omega. So this part will become the e into minus I omega. So e cancel. So del t equal to minus I omega. Okay. So del t equal to, I will directly put minus I omega. Or if it is minus, or if we replace minus I k, then del t equal to I omega. Okay. These two important is really important point to know. Number one. Okay. Now second time I am going to find the relation one. Relations one. First relation I am find out. So from the Maxwell equation, divergence of E equal to 0. See, del equal to Ik into E equal to 0. Is it okay? That means K is perpendicular to E. Is it okay? Similarly, second equation, if I look back the second equation, divergence of B equal to 0. Then this means Ik into E equal to 0, B equal to 0. That means K is perpendicular to B. Okay, from this equation we can conclude that K is perpendicular to E, perpendicular to B. What? From relation 1, I can understand that in electromagnetic wave, three possible variables, that electric field, magnetic field, and propagation the vector, all are mutually perpendicular to perpendicular to each other, like Cartesian coordinate system x, y, z. Okay, that is relation number 1. Relation number 2. Relation 2. What is the relation 2? Is suppose I want to find out the relation between electric field, propagation vector, and the magnetic field. So you can take any equation. I will take del cross E equal to minus this is a Faraday equation or Maxwell equation, third Maxwell equation. So I have already given you short tricks. Del equal to Ik into E equal to minus del equal to I omega into B. Is it okay? Minus minus cancel. So K cos E equal to omega B. Is it okay? This is the vector rules. Have you remembered that this formula A cross B equal to C? Okay, what is the meaning of this equation? That A cross B equal to C, that means C is an area vector. This area vector is perpendicular both B as well as A. Similarly, for a particular electromagnetic wave, omega is constant. Particular electromagnetic wave frequency is constant, omega is constant. Forget about omega. It may be you may consider this one. So B is area vector. B is perpendicular both electric field as well as magnetic propagation vector. That means their behavior is look like that. If it is propagation director K vector, this is E vector, magnetic field will be like this. So it is look like a rectangular coordinates axis. Okay. So I have already derived that K is perpendicular to E. That means angle between KE equal to, because this formula you know, A cross B equal to AB, magnitude of A, magnitude of B, sine theta, n cap. It's a unit vector. So this is 90 degree. This is 90 degree because they all are perpendicular. I simply write KE in magnitude form omega B. Okay. Omega B. So what is the meaning of this equation? B equal to Ke by omega. Okay. This omega means K means twice pi by lambda, and E, and this is twice pi nu. So if I cancel it, is E by C. This is the relation between electric field and magnetic field. Okay. So in free space, the what relation I am getting in free space, B magnetic field is written as this is the relation in free space. But in medium, B we have to replace E by V. V is the velocity in medium. This is the relation in this is in free space. This is in particular medium. Now forget about the medium. Now we focus on the phase relation between in free space. So what does it mean? The meaning in magnetic field, magnitude of in electromagnetic wave, magnetic field is C times smaller than electric field. Okay, C times smaller than electric field. That is why when we talk about the polarization of electromagnetic wave, we often talk about the polarization of electric field. Not polarization of magnetic field, because magnitude of B is C times smaller than electric field. So conventionally, suppose, have you remembered this equation? I don't know. I think you have remembered. This is a polarization equation. E y square B square minus twice EX EY AB cos delta equal to sine square delta. This is the equation of polarization of electromagnetic. EX means electric field. So polarization of electromagnetic wave means polarization of electric field. Okay. If you see David Gifford book, if you see David J. Gifford books, 379 page 379, and figure number 9.10. If you see, this fact is already they have written, but a mathematical reason they have not explained. They have written as by conventionally polarization of electromagnetic wave means polarization of electric field, but not polarization of magnetic field, because of this reason. Okay. Second point, this is the relation. But in case of medium, we have to B equal to E by V. Okay. Now V is the velocity of light. Suppose in that case, refractive index we have to introduce. Refractive index means C by V. Okay. C means velocity of light is constant and V means velocity of medium. So what does it mean? Refractive index means it is a constant value. Refractive index is a constant value. It will give information how fast electromagnetic wave move in a particular medium. For example, suppose refractive index N1 equal to C by V1. It is 1.5. Suppose this is a medium water, and this is a water medium, A medium. Okay, and another effective index C by V2 equal to 1.0. Suppose in medium B. Okay. What does it mean? So 1.5 means V is smaller because C is constant. So higher effective index means lower velocity of electromagnetic wave in medium 1, and lower effective index means high velocity of electromagnetic wave in that medium. So this is how refractive index is characterized. So refractive index will tell you how fast electromagnetic wave propagated in a particular medium. Clear? These are the important facts we have already studied. Now, if we do the calculation, see, if we do one or two calculations, suppose Now coordinate relations, coordinate relations. So these will help you understand the mechanism of electromagnetic wave, how it moves. See, in Cartesian coordinate system is represented by what? X cap, y cap, or you can z cap, or iz cap. You can write iz cap also. This is Cartesian coordinate. This is suppose spherical coordinate system, r theta cap, phi cap. Is it okay? And this is cylindrical coordinate system. This is clockwise, r cap, phi cap, z cap. But in electromagnetic wave also follow the same behavior. This is E cap, electric field, unit vector, B cap. This is K cap, unit vector, or S cap. Same rule follow all four coordinate system. Here, suppose if we take the cos y equal to x, y, it will be z cap. Or if we take the anti-clockwise, y cap into x cap, it will be minus z cap. Similarly here, r cap into theta cap equal to phi cap. Here also same rule follow, r cap into phi cap equal to z cap. Similarly, if we take the here electric field unit vector into b cap equal to k cap. Okay, k cap or s cap. Similarly, if we take anti-clockwise direction, b cap into e cap equal to minus k cap. The same rule follow all four coordinate system, and this will help you to understand the direction of electric field and magnetic field. Okay, and all remaining property, then I dot b equal to how much? I dot b equal to non-zero, and E dot E equal to 0. A cross product is 0. Cross product is this. If we see that I dot y, x dot y equal to how much? 0, because theta is 90 degree. Similarly, E dot b is 0, I have already told you, and E dot b dot k is also 0, k dot e is also 0. It will follow the same rule like a coordinate system. This is how you can remember. Now, if we do one or two problem, then you can easily understand numerical problem. See this question number one. Okay. See, if electric field is E is equal to Z T equal to E naught e to the power I k z minus omega t x k. This is the solution. Then find what is the value of B. This question comes in the NET or GATE exam, and if we solve numerical problem, then you can easily understand the behavior of the electromagnetic wave. Okay, now see solution. Solution is very easy. Okay, I have to find out B. This equal to B naught as per standard solution. Standard solution equal to E naught e to the power I kx minus omega t. B is equal to B naught e to the power I kx minus omega t. This is the standard solution. Now, this B equal to B naught e to the power I kx minus omega t. I have to find out. Now, before that, I am writing in terms of E. Okay, I will write E equal to E naught. Now, do not confuse, because k vector is associated with the x. That means k propagation direction is x cap, or you can say I cap also. Okay, do not confuse. And this x is direction of electric field vector. This is z. This is z. Z means it is propagating along z axis. Okay, k vector. Clear? And this E is associated with the x. That means E is along x cap, or you can say I cap also. If we see this diagram, electric field, magnetic field, and propagation direction or pointing vector. Now, what is the value? I have to find out B. So B means I have to take the cross product of K into E. So B equal to unit vector of B equal to K cross product of E. So K is propagating direction along K cap into E propagating direction I cap. K into I cap means what? C I J K. K into I cap means C. It is J cap, or you can say Y cap also. Okay. So, so what you can understand, B equal to B naught, B naught. This part will remain fixed, this part will not change, exponential term, and this will be Y cap. Okay. Now B naught is not here, so how can you calculate? Because I have already derived this relation. B equal to E by C. Is it okay? It is free space, in free space, free space. Okay. Then B, I have to replace E naught by C. This part will exponential part remain same, kx kz minus omega t. This part will be y cap. This is the solution. Nothing to do anything. Okay. This is how we have to find out. Another solution, suppose. Another solution. I strongly suggest you to read the David field book. Another suggestion is, suppose if electric field, question number 2, if electric field ERT is equal to E naught by C cos K dot R minus omega t plus delta is a phase shift, don't worry, K vector into n cap. Find B and B vector. This question comes in the NET exam, so it is very easy. Solution is very easy. So this part will remain fixed. Only we have to find out the direction. Now what is the direction? See, wave vector is propagating, because this is a three-dimensional solution. The wave vector is associated with x, r. That means wave vector propagating along k direction. You have to write like this: E vector, E cap, B cap, K cap, or S cap. Now this is C. E is already given. Direction of E vector is this one. So direction of E vector, unit vector, is this one: K cap into n cap. So direction of propagation vector is K cap. It is not bigger. It is three-dimensional. That means it is along all three directions. This is simply write as a K cap vector. So what is the? I have to find out B. B means what? We have to do clockwise. So B equal to unit vector equal to K cap into E cap. So K cap, E cap means K cap into n cap. Simple. So it is look like I have already told B cap C equal to this is the vector triple product B A dot C minus C A dot B. This is the formula, vector triple product. This is B, this is C. Then you will find equal to B means K equal to A means K cap dot n cap minus C n cap, then A dot B n cap K dot K. Okay, so finally you will get n cap. Finally you will get n cap. This is a vector triple product. You see the focus. So magnetic field vector, I will get the n cap. A cross B equal to A dot C. I have already given that formula. And another problem, numerical problem, B dot A dot C. So n cap. So B solution equal to, I have already given B solution, because B naught, this cos part will remain same and equal to n cap. Okay, and B equal to E. This is E naught by C. So B equal to only how much? B equal to E naught by C. E naught by C is already given. So it will be B naught, and cos term this solution. Cos. Okay. This is the solution. This is very easy. Now, secondly, I will focus on the energy of electromagnetic wave. Energy of EM, energy of ENB in EM. So, in electromagnetic wave, electric field is main component is electric field and magnetic field, and another third component is K vector. Ke vector only give the propagation, nature of propagation. Okay, so we have to focus only two variable: time dependent electric field and time dependent magnetic field. Now my question is that how much energy, so in electromagnetic wave, energy associated with the electromagnetic wave, how much energy shared by electric field, how much energy shared by magnetic field, that's what we have to know. Okay, but although magnitude of magnetic field is C times smaller than electric field, but energy shared by electric field and magnetic field are equal. This information is very essential whenever we see, for example, whenever we send a electromagnetic signal from one point to another point, suppose source to destination through a guided medium or optical fiber, then we have to know how much energy lost during the transmission. Okay, during transmission throughout the channel, we have to know. For example, signal to noise ratio, we have to know. So that is why, and another important thing, electric field vector as well as magnetic field vector depend on the channel medium through which the electromagnetic wave propagated. So first of all, we have to calculate the energy shared by electric field, magnetic field. Probably you have remembered electric field energy is equal to 1/2 integration E dot D displacement vector dV. I assume that you have already seen this equation is already given in the previous electrostatic chapter. Okay, D is the displacement vector, E is electric field. But in case of free space, D equal to, I have already told you, epsilon naught E in free space. So E dot epsilon naught E dV. So A dot A, this is A dot A, like A dot A means A square. Similarly, E dot E epsilon equal to 1/epsilon naught E square will come out. Integration of dV means V. This is the energy of electric field. And then energy density of electric field UE by V equal to half epsilon naught E square. This is the energy density of electric field in electromagnetic. This expression is used in calculation of energy density in electromagnetic wave. This is the density. Okay. Similarly, if we see the magnetic field energy, of magnetic field, we have to calculate same formula, B dot H dV. Okay. And B equal to mu naught H. So if I take this equation, similarly previous equation, mu naught B square V. So energy density, so magnetic field energy density 1/2 mu naught B square. Clear? This is the energy formula that we are going to use in order to calculate the energy associated with electric field and magnetic field. Okay, now suppose we are going to calculate the average energy. This is the formula 1/2 epsilon naught E square. This is the magnetic field energy 1/2 epsilon naught B square. Okay, now if I take the electric field is equal to E naught I kx minus omega t. So I cannot use this formula here. Then I have to convert this equation in trigonometric function. E naught cos kx minus omega t plus I sin kx minus omega t. Now I get this is the real part. This is imaginary part. This means real of E, okay, plus I imaginary part of E. You can take this part, you can take this part, answer will remain same. So real E means real part E naught cos kx minus omega t. Similarly, imaginary part this means. Okay, or I can, so I simply take the real part. I assume that electric field in trigonometric form is equal to cos kx minus omega t. Or if you want, you can take E equal to E naught sin kx minus omega t. Result in this case will remain same. So energy density mu V equal to half epsilon naught, then E naught square cos I take cos kx minus omega t. Is it okay? Similarly, magnetic energy equal to 1 by mu naught. This is E naught by c square. C square, there is a relation. So cos square kx minus omega t. Is it okay? These are the this is the relation 1a1. This is the instantaneous. A2 is the instantaneous energy. Okay. Instantaneous. Now average energy. Average energy. In ACES you have already studied AC power, DC power, voltage, ripple factor. So RMS value. So whenever AC current is I equal to I naught cos omega t, then this is the instantaneous current. So in that case we have to calculate the average energy, average power, average current. Okay. So average relations, how can we calculate average relation? So average velocity, average energy, this is a constant term. You cannot take the average of constant term. This equal to gamma E naught square. Is it okay? Then cos square kx minus omega t. Okay. Similarly, magnetic energy, average magnetic energy 1 by mu naught E naught square c square cos square kx minus omega t. Okay, and now see, if you take the sine part, then it will be sine square, it will be sine square. Now now how can you take the average value? You have to remember the average formula. Average formula is this one. Okay, 0 to t dt integration 0 to t ft dt. Is it okay? This is the average formula. Or in terms of theta, you can write 0 to twice pi d theta, 0 to twice pi. Okay, 0 to twice pi f theta d theta. This is the formula. So if we take the average of cos function, any function, theta suppose, it will be L equal to sin theta value equal to 0. If you put this value, you can say I am not going to do. And now if it is sine square, then it will be sine square. It will be sine square. Average value is half. So average of cos square, any function, whatever it is, equal to half. Average of sine square, if you do the calculation using formula, I am not going to do, is very easy, half. Okay, another way you can remember, since sine square theta plus cos square theta equal to 1, okay, sine square plus cos square theta equal to 1, so average value of sine theta, average of sine square must be equal to half. Similarly, average value of cos. So using that average value, mu energy, average energy is equal to half 1 by 4 E naught square, square. This is average of magnetic field is equal to 1 by mu naught E naught square c square. This is 4. Now if you see c equal to 1 by c square equal to 1 by mu naught epsilon naught. If you put this value, you will get 1 by 4 epsilon naught e square. That means energy equal to energy B. Okay, so that means I am stopping here. That means in electromagnetic wave, total energy is equally shared in between electric field and magnetic field. Clear? So in the next class, I will discuss the Poynting vector, which is important. Poynting vector measures the total energy flux. Okay, S is a Poynting vector, total energy flux coming out from a particular source toward the destination. Okay, after this part, thank you. So if you have any question, if you have any doubt, you can send me SMS. Just you try to understand the nature of electromagnetic wave, how we represent the electric field and the solution, and what is the physical meaning of each equation we have to understand. Then we can easily understand communication, waveguide, transmission line, and optical communication, fiber optics communication, we can easily understand. This is the basic requirement. And another important thing that I have told you, that whatever the solution I am writing here, this is the Cartesian solution. And this, because whenever we talk about the communication or propagation of electromagnetic wave through a cylindrical pipe, okay, then we have to take the solution of the wave equation in a cylindrical coordinate system according to the problem defined. Then we have to understand the solution of electric field and magnetic field, which are the solution of wave equation in coordinate system. In the next class, we'll discuss how coordinate system is related to describe the behavior of electric field and magnetic field through a particular medium. We will discuss later. Okay, thank you. I hope you understand. These are the basic information, and through which you can easily understand the remaining part that are associated with the waveguide and transmission line. Thank you.